All right, central limit theorem. This first part kind of explains what the central limit theorem is. So if I have a mean IQ of 100 and a standard deviation of 15, what do you think would be more rare? A person with an IQ of 80 or 25 people with an average IQ of 80? So this is going to be a lot more rare because here you need all 25 people to fall into this 80 category versus over here you only need one person to fall into the 80 category. Okay, so this one's going to be more rare. Find the probability of having one IQ less than 80. So the way you do this is you're going to do normal CDF, and your low bound's going to be something big and negative, so negative, we'll call it negative 100, comma, your high bound's 80, your mean's going to be 100, and your standard deviation is going to be 15 because there's only one of them, right? So these are all very, very similar problems. Second distribution, normal CDF, negative 100, 80, 100, 15. So I got a probability of 0.0912. Okay, so about 9%, 10% of the time. Okay, over here we're doing the same thing, but instead of having one person, we're going to have an average of 9 people. So the only thing that's going to change is that the standard deviation is going to be 15 divided by the square root of 9. So this is going to be normal CDF, and then the low bound is going to be like negative 100, just like before. High bound is going to be 80. The mean is going to be 100. And the only difference is the standard deviation is going to be 15 divided by the square root of n, which is 9. So you can do that on a calculator really easy. You just change 15 to 15 divided by square root of 9, which is 3. Enter, you get 3.16 times 10 to the negative 167 times 10 to the negative 5th. So that's pretty small. Over here doing the same thing, but instead of having 3 people, we're going to have 16 people. So again, it's going to be normal CDF. And then it's going to be negative 100, 80 for the mid, so negative 100 is over here, up to 80, and then 100 is the mean, and the standard deviation is going to be 15 divided by the square root of 16 this time. So 15 divided by the square root of 16, when I type that into the calculator, I get 4.8332 times 10 to the negative 8th. Dang. So really small. So as you can see, these probabilities start off at 10%, and then I want to average it out of 9 people and 16 people. These probabilities are going down and down and down. E is the same thing, but instead of having 16 people, now we have 25 people. So we're doing the same thing, normal CDF. Down here is negative 100, comma 80, comma the mean, comma the standard deviation, which is 15 divided by the square root of 25 this time. So we do that on the calculator, we're going to get something crazy small, 1.315 times 10 to the negative 11th. So what happens? So if I were a statistician and I got this answer, I would say that having an IQ of 25 people less than 80, an average IQ less than 80 probably can't happen, right? Because this is a ton of standard deviations away from the mean. And this probability here is really, really small. So NGH, what happened? Well, it's never going to happen. Cool. Number 2, find the standard. So they told me the mean is 55. So go ahead. I want you to get really used to drawing your curves, right? So this is going to be 55 in the middle, and then we want a sample of 4 people. So it's going to be 10 divided by the square root of 4. So here that's going to be a standard deviation of 5. And this one, you can tell that the standard deviation is going to be smaller if I have 100 people versus if I have 4 people, because the probability of having a mean of 100 people is going to be a lot tighter than the probability of having a mean of 4 people. It's going to be a lot more spread out. So this will be 55. This will be 10 divided by the square root of 100. So that's going to give me a standard deviation of 1, right? Much smaller. So here you'd have a standard deviation of 5. Here you'd have a standard deviation of 10. Why is 10 smaller? We talked about it before, because we have 100 people. Oh, this should be a sample of 100, not 10. Tougher to get an average of 100 people versus an average of 4 people. All right, here we go. Mean, room, and board. So the mean is going to go right in the middle, 6803, and the standard deviation is going to be 1125. We're going to find the probability of one thing or one person, one college being less than 7,088. So that's going to be right about here. So we're going to go everything under here. So if I were typing this, 7088. If I were typing this in the calculator, I would do normal CDF. And then I would type in the low bound, which is like negative 100 or negative 1,000 or whatever you want it to be, up to 7088. And the mean is going to be 6803. And the standard deviation is going to be 1125. So let's go ahead and type that in real quick. Second distribution, normal CDF, negative 100. Oh. Negative 100. And then upper bound is going to be 7088. Mean's 100. No, the mean is 6803. And the standard deviation is 1125. Probability of that happens about 59.99, so about 60%. So pretty high. Now compare that to what's going on here. Out of 9 schools, so the mean will stay the same, 6803. This value will stay the same. We're looking for everything less than that, 7088. The standard deviation, though, is going to be 1125 divided by the square root of 9 schools. So n always goes in there. So we do the same thing, but we change our standard deviation. The standard deviation is going to be that divided by the square root of 9, which is obviously 3. So it's going to be... Make sure I did that right. One 0.0025 divided by square root of 9, which is, so I got 0.776. Right, so the probability actually went up because this gets smaller, so this is going to actually take up more of the curve if I go this way. If I went before the mean, it would take up less of the curve. Okay? Last part, we're going to remember how to use invert norms. So we want to find the 90th percentile. So we want to find that z-score for the 90th percentile. So we type in 0.9 here, so we're going to go invert norm. And then we're just going to type in 0.9. That one's easy. Second distribution, invert norm, 0.9. We'll just leave mean 0, standard deviation of 1, and we want the tail to be to the left, right? If you have the older calculator, you're going to get the tail always to the left, so you have to kind of make some adjustments here. Z equals 1.282. So that's my critical Z value. Upper 30%. So my upper 30%, I want this tail to be 30%. So my percentile is actually going to be 70%, because if you have the old calculator, everything goes kind of to the left. All the tails are to the left. So we want the tail to go to the right, which means we have to subtract from 1. So we go invert norm, and then we do 0.7. Invert norm, 0.7, enter. We get a z-score of Okay, upper 7%, so that's the same type of thing here. Upper 7%, so we want this tail to be 7%, which is 0.07, so we want this to be 0.93. So we want to go invert norm of 0.93. Invert norm 0.93. Enter. We get 2.475. Now, all of these are positive because they're all above the mean. If they were below the mean or below the 50th percentile, they would be negative z-scores. So like this one, we want to find the negative, or the middle 90%. So the middle 90%. We're going to have two z-scores. We're going to have a negative one, and we're going to have a positive one. So the middle 90% means that I have 5% in this tail and 5% in this tail. So I'm going to go invert norm 0.05, right? And I could do 0.05 or I could do 0.95. It doesn't really matter. So invert norm 0.05 to the left. So that'll get the negative one with negative 0.644, and the positive one will be positive 0.644. So this one actually has two z-scores. You have negative 0.644 and positive 0.644. And then finally, the middle 95%. So the middle 95% is going to be, let's see here, draw your curve. So we want this to be 95% evenly distributed. So that means I have 5% left to play with. So this will be 0.025 over here, and 0.025 over here. So I'm going to go, I can either do invert norm 0.025 or 0.975. It doesn't really matter. One will give you a positive z-score, this one. One will give you a negative z-score, this one. So I'm going to do invert norm. I'm going to do 0.025. Enter. That's going to give you negative 0.959 and positive 0.959. Invert norm 0.025. Let's make sure I did that right. Invert norm 0.025. Going left. That's what I thought. Oh, that's weird. I wonder why I was doing that. It should be negative 1.95, yeah. Negative 1.95. And positive 1.95. I bet this one's wrong too. Let's double check those numbers real quick. So let's go second distribution, invert norm. 0.05 going to the left. Enter, negative 1.64. So this one's positive 1.64, this one's negative 1.64. All right, I'll post this. I'll post the answer key. Check it out. Let me know if you have any questions during office hours. Peace.